Dbms, and then we'll do the object-oriented programming. Share screen. Okay, I'll do a quick recap. So, advantages of database management system. It creates and manages database. With the help of DBMS, programmers can easily retrieve, create, update, and manage data. And there are various functions provided by DBMS which gives an upper hand over the traditional file system. Users can also create their personalized database as per the requirement. So, key things on this one is creates and manages database. Um, Programmers can easily create, read, update, and manage data. And functions performed by DBMS, upper hand over traditional file system. You can get personalized database as per requirement. Okay, so creates and manages database. Programmers can easily retrieve, create, update, and manage. Functions performed by DBMS gives an upper hand over traditional file systems. It's better than traditional file system, and users can also create personalized database. Okay, what's the advantage? We already discussed that. I think we'll discuss a few more. Ease of accessing. In file system, the database files are created for each user containing which each user. Okay, I think there's a mistake in the file. In file system, different files are created for each user. User, which they can access. In file system, different files are created for each user. Uh, DBMS removes redundancy by granting access to users and decides which and how many parts of the data is accessible to them. Storage management of the data. Unlike file system, data can be directly stored in form of an object. Okay, making it easy to query. This is important. Avoiding duplicate and redundancy. In the file system, storage data might take place multiple times. Storage might take or might happen. See, it's better, easier to read. Might happen multiple times. Data normalization is used to avoid duplicate data. Concurrent data. User can access data simultaneously to different application. Simultaneous access of data. Database integrity means the data should be accurate and consistent. This implemented by enforcing checks and constraints. So data should be accurate and consistent. How it is done? It's done by enforcing checks and constraint on the data. So we've kind of taken a summary of what it is. The first is ease of accessing. In file system, different files are created by each user. In DBMS, we grant the access to the users and deciding which and how many parts of data is accessible by them. So it removes the redundancy, but in the file system, we create different files for each user. So everything inside of that is available to that user. But here, we can manage the access better because we can decide what part of the data can be accessed by which user. So ease of accessing. Storage and management. Data can be directly stored in form of an object, and it's easy to query from an object than from a file system. Okay, in file system, storage might happen multiple times, but here, because we use data normalization, we kind of divide the table into uh, efficient table to avoid duplication of the data. Users can access simultaneously through different applications, so concurrent data accessing. And database integrity means that data should be accurate and consistent, and this is implemented by enforcing checks or constraints on the data. Okay, ease of access, storage and management, directly stored in form of object, easy to query. Storage can happen multiple times, but here you have normalization, so avoiding duplicates and redundancy, and accessing the data simultaneously. So these are your advantages. The types of DBMS architecture, you have physical and logical. Logical defines the data organization and access at different logical levels. Physical defines various components of database software. For example, DML precompiler, DDL compiler, file manager, database manager, query processor, administrator, data files, indices, and data dictionary. So logical is more to do with the logic and the structure of the data. Physical is more to do with the software component. Okay, so three level database architecture. You have external level or view level, conceptual level, internal level, or physical level. And this is actually where the database is stored. So three level database architecture was designed by ANSI for data abstraction for different types of users. So key thing to remember from this point is designed by ANSI for data abstraction for different types of users. So it was designed by ANSI for data abstraction for different type of users. Three levels are physical level or internal level, conceptual level, logical level, external level or view level. Physical or internal level is the lowest level in the three level architecture. First point is easy to remember. It's like just describing the diagram. This is the lowest level. This is the second highest level. This the most highest level. So first point is like easy. Second, it describes how data is actually stored into the database. So the how factor. In the lowest level, data is stored in external hard drives in form of bits, and at a little higher level, it can be said that the data is stored in files or folders. So the key thing to remember from this is data is stored in external hard drives in form of bits. Okay, so it's the lowest level out of the three level database architecture. Describes how data is actually stored into the database. In the lowest level, this data is stored in external hard drives in form of bits, and this level also discusses compression and encryption techniques. Then you have the conceptual level or logical level. So conceptual level is at the higher level than the physical level. Purpose is to define the structure, relationship, and constraints of the database system. So the previous one, which was the physical level, that was responsible of deciding how the database is stored, and the database stored inside of the hard drives in form of bits. But the conceptual level defines the structure, the relationship, and the constraints, the limitations on the database. So again, key point to remember is defines the structure, relationship, and constraints. Okay. Describes how database appears to the user conceptually and the relationship between various database tables. It does not care how the database is actually stored. Okay, so what are the key points? First is define structure, relationship, and constraints. Describes how database appears to the users conceptually and relationship between various data tables. Does not care how data is stored. Okay, again, a recap. So physical level is basically the very first level, the lowest level, and physical level is actually going to decide how the data is actually stored into the database, and it is stored in hard drives in form of bits. It also discusses compression and encryption techniques, and conceptual level is basically going to define the structure, relationship, and the constraints of the database system. It doesn't care how the database is stored because that job is taken care by the physical level. It just describes how the database is going to appear to the users conceptually and the relationship between various tables. Now I talk about external view level. This is the highest level in the three-level architecture and closest to the user. It only shows the relevant database content to the user in form of views and hides the rest of the data. So different user can see the database as a view as per their individual requirement. So key points to remember from this: only shows relevant database content to the user. Different users can see the database as different view as per their requirement. Okay, so highest level only shows relevant database content to the users, and different users can see database at different view. Okay. Now we talk about database independence and its relation with the three-level DBMS architecture. So I think the main point about the database independence is that uh, all of these levels are independent to each other, and a change in one of them should not affect the change in the other. So change of data at one level should not affect another level. So we should be able to modify schema at one level of the database without altering the schema at the next higher level. The three-level architecture defines a single database system across all the three levels. Therefore, different levels must map with each other. This mapping leads to the concept of data independence. There are two types of data independence: physical data independence, which is defined as the capacity to change the internal schema without having to change the conceptual schema. If we do any changes in the storage size of the database system server, then conceptual structure of the database will not be affected. It is used to separate the conceptual levels from internal levels. Okay, so again, key things to remember is that change of data at one level should not affect another level. That's the main thing. Modified schema at one level without altering Next higher level. Single database across three levels. Therefore, levels must map with each other. Physical data independence defines capacity to change the internal schema without having to change the conceptual schema. If we do the change in storage of the size of the database server, then conceptual structure of the database will not be affected. So change in size structure will not be affected. Separate conceptual level from internal levels. Physical data independence occurs at logical interface level. Okay, move on. So let's do logical. Okay. So there were two types of data independence. One is physical and second is logical. Logical data independence refers to the characteristics of being able to change the conceptual schema without having to change the external schema. Logical data independence is used to separate the external levels from the conceptual level. If you do change the conceptual view of data, then the user view of the data will not be affected. Logical data independence occurs at user interface level. So basically, if you see, this is just a repetition. The physical data independence content that you see is getting repeated here also in the logical. The only difference is that uh, in that three level architecture, logical is going to happen, this data independence is going to happen at one step up, which is at the user level. And the physical level is will also happen at the one level up, which is logical level. Because if you look at the tree, how they're sitting, we have the physical level, conceptual level, and user level. So physical level data independence happens at conceptual level, and conceptual happens at the user level. And all they are saying is that if there's any change in the schema at the physical level, it's not going to change anything at the conceptual. When we talk about the other data independence, it's saying that any change in conceptual will not change anything for the user or to the external level. So these are basically your three conceptual, three database level architecture, which is I think important in with respect to exams. And if I have to summarize these in one lines, this talks about how the data is stored, which is this one, like in hard disk in form of bits. Conceptual is mainly to do with the structure, the relationship, and the constraints of the database. And external is mainly responsible for the user, what the user is going to see. Not all the user are not going to see everything in the database. They're going to see the relevant information, which is basically important for them. So so that's a summary of all of these three levels. Okay, moving on. Okay, now we talk about the physical. So yeah, I think there were two type mainly. Where did it go? Yeah, here. So what were the two types of DBMS architecture? One was logical and second was physical. So we just spoke about the logical one, and which logical one had these uh, three levels which we spoke about. Now we'll talk about the physical database architecture. So let's do that. Yeah, this is a physical database architecture. All right, so this defines software components. So your other one spoke about the logic and stuff. This is mainly do with the software components like compiler and processor, manager, all of those things. and how they are interrelated, interconnected. There are a number of key functions which are similar to most of the database management system. The components are normally execute these functions are shown over here. So you have general users, you have application program, then object code of program, DML pre-compiler, query processor, DDL compiler, database manager, file manager, data files, data dictionary, all of that. That's your structure. I want somebody else to read it. I'm tired. Kritika, do you want to read it?
Yes, okay.
Okay. Yeah, but you have a background music also. That's good.
I'm actually at an office and they play her, so I really can't control this. Sorry.
That's okay. That's okay.
um, okay. DML precompiler. Every DBMS consists of a data manipulation language, which is used for data insertion, modification, data access, etc. The purpose of DML precompiler is to translate the DML commands, which are written as part of the application programs, into related procedure calls so that they can be executed to perform the desired operation. In addition, this component of the DBMS also coordinates the translation of queries, which are input to the query processor component. DDL compiler. It is used to compile a DDL statement into the related tables, which include the metadata, constraints, access rights, etc. The metadata tables are stored in the data dictionary or system catalog. This metadata is used for providing information about the tables to other components of DBMS, protecting data and enforcing data integrity.
Okay, so just to recap, pre-compiler is basically going to translate the DML commands so that they can be executed to perform the desired operation. So let's just highlight the main thing from this. Translate DML commands so that they can be executed to perform desired operation. Okay, and then uh, compiler used to compile the statement into related tables. Yeah. So the pre-compiler, DML pre-compiler, is going to translate the DML commands so they can be executed. DDL compiler is going to compile the statements into related tables. Go on.
Okay, I've come to a quieter place now.
Good.
Um, File manager. All the tables and metadata of the database are physically stored as files under the control of a file subsystem of the operating system.
Okay.
The file subsystem of the operating system has generic features which may not be sufficient for a DBMS file.
Mhm.
The file manager component of the DBMS keeps track of all the data files, their index files, and all other related information files of a database system.
Ritika, this word is pronounced as component.
Component, okay. A database manager. The role of database manager is to accept the requests of data access or data manipulation by the user queries and application programs and performs the relevant action on the data taking the help of data dictionary and file manager. Database manager protects the data from unauthorized access and manipulation. It also enforces integrity constraints.
Okay, so let's kind of summarize this. So, file manager, all the tables and metadata are physically stored in file as control file subsystem. Subsystem operating system generic features may not be sufficient. Component. So, what does it do? It basically keeps track of the data files, their index files, and other related information. Okay, so this is the main thing. Database manager role is to accept the request of data access by the user queries and application programs and performs relevant action. So to recap this, the main job of file manager is to keep the track of all the data files, the index files and all the related information. Database manager accepts the request of the data access by the user query and performs the relevant action by taking help from data dictionary and file manager. Also protects the data from unauthorized access is another one. Protects data from unauthorized access and manipulation. Enforces integrity constraints. So many things it does. File manager keeps track of all the data files and related information files. Database manager accepts the request by the queries, performs the action, necessary action, protects the data from unauthorized access and manipulation, and enforces integrity constraints, which means whatever rule has been applied for that data table, that rule is enforced by the database manager. The file manager is to do with the files, like keeping track, and database manager is like protecting your data from unauthorized access, enforcing that all the rules are followed, performing relevant action based on the request that comes in. Basically, kind of managing the data. So we like almost did a post-mortem of this. Okay, go on.
A major components of database manager. Authorization control is used to verify the credentials of a user to ascertain if he or she is an authorized person to access or modify the data. Command processor converts the DDL or DML or other programming language commands to executable sequence of code. Integrity checker checks if the data that is being inserted in a database or is being modified follows all the specified constraints on the database. Query optimizer tries to optimize the processing time of different queries. Transaction manager is one of the important components
Yeah,
which,
good.
which which checks if the user has right to perform a transaction.
Mhm.
Scheduler component manages the consistency of data while concurrent transactions are being processed by a database. Recovery manager is responsible for recovery of a database system to a consistent state in case of a failure. Buffer manager optimizes the process of transfer of data between main memory and the disk where database is stored. The
Yeah,
buffer manager
go ahead.
the buffer manager is also termed as the cache manager.
Okay, the plan for next week is that next week we're only going to practice those questions which are in the assignment and as well as in the question paper. Once we are kind of sure and confident that we have learned those and we can write those without even looking, then we will move on to anything that is not important, because it is not possible to cover every. Of course we have covered everything in these sessions, but in terms of revision it's not possible to cover everything in short span of time. So next week plan is to cover two subjects. So which are the first two? uh, Database
Data
management.
structures and all algorithms.
Algorithm is when?
I don't know.
I think
I'll
It's
check.
on 2nd
that
September.
second. Okay, okay, no problem. So since we've not done the algorithm yet, we'll probably just do the revision of these two. And algorithm is something we'll start after the first exam is over. Okay. if I get a chance to get to it, at least some content of that, I'll cover that next week. Maybe we can have two sessions, morning and evening, something like that. But yeah, main thing is to make sure everything that is there on the assignment and on the question paper is, we are thorough with that. Like we can write it without looking. So a lot of repetition of the same answer again and again, so that it gets into our head, and then we leave everything as like these guys which are not there, they're just in textbook. These guys will do if we have time. Okay, go on.
Okay. Have you studied DSA,
uh,
data structures and algorithms?
Actually, I've watched a few videos, but I really haven't got time to do that. Is because I haven't still completed database management system. I think I'm here. Where is it? Mm, I'm on the DML. Where is DML? Sorry, data control. Yeah, I'm over here. I still have to do all of these guys and then one on the right. So I didn't want to jump onto that without completing this. I know that I'll have around 1 week, not 1 week, but 5 days after the database management is over. So probably I'll keep my focus on the algorithm at that point of time. I'll of course study during the weekend, but at least some part of it. But then I'll focus that at that point because keeping a goal that at least Java should be off the list, um, by the end of
Mm-hmm.
next week. So I don't have to worry about at least one subject.
Okay, got it. Yeah, that makes sense. I was just wondering, I find DSA more difficult than these two.
That we have to check with Sumaya.
Yeah.
She's done
How did you
so
find it, Sumaya?
Only the first unit was a little difficult.
big on notation.
Um, yes, and the
Uh,
unit on trees. I finished half of it, and only those 2 units were hard. The rest was easy.
Did you study by the book or did you watch any videos?
Yes.
Mostly with the book.
Yeah, because we don't have time to watch the video. I know there's so many guys who take so much time in, just talking here and there rather than just focusing on explaining the topic.
We
So it
should
consumes
speed up
more
the
time.
videos.
Yeah, sometimes I skip it. Like I skip the jargon.
I think I don't understand anything if I don't watch the video first, because if I directly jump to the book, then I'm like, what is this graph? Why are you here?
Some people are better
So,
learners through video, while some are, enjoy reading.
yeah.
So depends on which type of learner, visual or reading.
I like reading too, but I think computer applications, I haven't
Boring, I
studied
think.
that before, so it's difficult. I
For
think
me
that's
it's even more
constructive.
difficult because for 8 hours, like I just finished my work at 6, and I was in
Hmm.
the middle of the task, and then I have to now learn, so my mind is like already exhausted. So
Hmm.
it's really hard for me, and I'm already working into programming, so that's why these things make sense to me, but some things still don't make sense to me. Some things are like really really boring.
Hmm. Okay.
So the database architecture that you are studying, the theory part, I have already kind of practically used for the clients. In fact, my own website that you see, all the data is everything
Oh.
I have written for that. So all the content that you're seeing that you're able to view, there's a whole database for that. So that's all coming from there.
Oh, this is so cool.
Yeah, I think I've created lots of courses here, like on Chrome, CSS, JavaScript, Next.js, Laravel, React, Python. Yeah, a lot of different courses you can find here. You can go to these courses and check out these courses are.
Nice. you,
Anyways,
you,
let's
st-
get back to this. What are you
you
saying?
start, you're starting to become a professor, right?
My idea is to travel the world and teach people.
Yes.
But in order for you to teach, you need to gain knowledge. That's what I'm doing.
That's
So
awesome.
yeah, and
Study.
the reason why I'm doing this course is for two reasons. Because I don't have an engineering background. I kind of just learned the programming myself. So it's good to have this degree, and plus this degree will help me, get a student visa in Canada. So
Hmm.
that's what I'm applying for. Let's hope I get good marks and I get an admission there. So once you go to Canada, then going to other places like Europe is close by from there compared to from India.
Yes, yes.
I've just been to Europe in the month of June. So I was there 14 days. I traveled to Switzerland, Italy, and
Wow.
yeah, let me just show you the pictures quickly. So it opens up mine. Yeah, so this is Switzerland. This is again Switzerland. This is your France. This is Italy. This is Paris. Yeah, Tower.
Amazing.
This is Switzerland. Yeah, this is the Disneyland in Paris. It's Amalfi Coast. So yeah, kind of really enjoyed the trip.
Did you go for like traveling or for work?
So there was an event called WordCamp Europe. This was the event basically. Okay, and I was invited to speak at this conference at this stage. So that's why I went there. So I thought if I'm going so, and this is where the party was given to it at this cruise. This is in Portugal.
Um,
So, so I said if I'm going so far, which was like sponsored by my company, I thought if I'm going so far, why not go ahead and convert this into a pleasure trip also.
wow.
The
Was
best
this
thing
a
I had was the
was this a
breakfast.
tech conference?
Yeah, tech conference. Correct.
Oh.
So this was WordCamp Europe. Yeah, come on, open up. Yeah, this is me speaking at this event.
Oh.
These all you meet all those people in that event and all these guys like from all part of the world.
Oh, you were
So
a speaker as well.
yeah, I was invited to speak at this event basically.
What did you speak about?
Spoke about the future of web basically. How and in which direction it's heading. That's what I spoke about.
Hmm. Nice.
Cool. Let's get back.
Yes.
We all want to get good score. Let's go there. Okay,
Yes.
keep on.
Okay. Query processor.
Hmm.
Every DBMS consists of a query language which enables database creation, data manipulation, data retrieval, and data control operations. In general, this query language processes consists of two basic components. The first one passes the query language into the native database language, and the second optimizes the query and prepares the code for query execution. The parser checks the syntax of the query, converts the query into a sequence of tasks, and sends these tasks to the query optimizer. The query optimizer is responsible for generating a set of alternative query evaluation plans. Database administrator. The role of database administrator DBA is to monitor control the database creation at different levels of three-level architecture and mapping between the levels. Modification, access, query response time, security, recovery in case of failure, etc. Data files, indices, and data dictionary. Data files. The data is stored in the data files. Data files can be standard files or encrypted files. These files, in general, are not accessible directly to any system user. Indices are stored in the index files. Indices provide fast access to data items. Data dictionary or directory is designed to store metadata, which is data about the data in a database system. A good data dictionary allows efficient data access as it can provide a roadmap to guide users to access information within a large database.
Okay, I'm not going to the explanation mode for the ones that are not
Hmm.
asked in the paper or in the assignment.
Data models and trends. A database system requires that the data should be structured in such a manner that it allows easier data access and manipulation operations. There, these structures are termed as database models. Conceptual model, user entities, their attributes and relationships among entities. Hierarchical model uses data hierarchy. Record based logical models. Object based models use objects as key data representation components. Semi structured model uses user defined tags. Database backend. Most of the database systems are deployed in a multi-user environment, either as centralized or distributed system. A database server, which is at the backend, manages and controls the physical data. It also provides integrity, security, and access control to multiple clients' requests. Need of utilities in commercial database system. Utilities are special purpose software which are provided to support additional features in support of a DBMS. Two such utilities are for backup or restore, to protect data against any failure, and load unload, to load data from one hardware or software.
Okay, so some of the questions like this you'll see when you see question mark like these are basically from the textbook, check your progress section where they've asked questions. So I've kind of put it here so that sometimes it could be useful.
Hmm. Okay.
The need for commercial database utilities are special purpose software which are provided to support additional features in support of database. Two such utilities of backup or restore to protect the data against any failure or load unload. So what is the use of these utilities? It's basically to backup or restore to protect the data against failure or load or unload. Okay. So in case something fails, it kind of because it's backed up, it loads or unloads the data. Okay.
Yes. A network model, a difference between network and hierarchical models. A network model stores of basic entities as data records, and points are used to represent the relationship between them. A hierarchical model uses almost similar model to represent data of the entities, but the relationship between them is implemented as a hierarchy.
Okay. I'll talk about relational database. So relational database management system. A relational database management system is based on the relational model introduced by E.F. Cord. E.F. Cord is known to be the father of database management system. He was the one who introduced this basically, and there are different database relational database management systems. For example, SQL, MS SQL Server, IBM DB2, Oracle is one of the most popular one. MySQL is what WordPress uses, which is very popular. And you have Microsoft Access. Uh, these are all the examples of the relational database management system. So we are studying what we are studying data, how to manage the data in the database management system. Now we are talking about the type of database management system which is relational, where everything is based on a relation between different tables, different data entities, etc. So now we're going to discuss more about these relations. Uh, this database uses tables to store data. Each table is called a relation, okay, which is a collection of related data entries and contains rows and columns. You already know what table looks like. You have rows and columns. Similarly, this is basically data is stored in form of table. You have rows and columns. Let me just quickly open and show it to you how it looks like. Um, Hopefully my terminal cancel it. This is my server for PHP MyAdmin, which is a workbench for working on the data. So this is using relational database management system. Which one is it using actually? It's using the MySQL, this one. The different RDBMSs. One of them is MySQL. I'm showing you an example of MySQL. So here you can see that it's a table basically. Table, you have got rows, which are these guys. These are rows, and then you have columns. So the vertical ones. So let me show you 1 second. Let's open one of the. So you see these rows, and then you have columns like post author, post date, post GMT. So these are columns. So I'll move it here. So each table is called a relation. So you can see the multiple tables here. There's posts, there is terms, there's users. So each of these tables are called relations, which is a collection of related data entries and containing rows and columns. Each table represents some real world object such as person, place, or event, or about which the information is collected. So if you're writing a blog post, this will contain the post. If there are multiple users registered, so all the user data will come here. So that's all. Let's move on. So let's repeat, what is a relational database management system? Well, it is based on relational model. That's the word you need to remember. It's based on relation model, and some of the examples are MySQL, Oracle, SQL, all of these. It uses tables to store the data. Each of these tables are called relations, which contains your rows and columns. Each table represents some real world objects such as person, place, events about which the information is collected. Okay, so what's the difference between a relational database management system and object oriented database management system? So we haven't studied the object oriented management system, but it's where the data is stored in form of objects. So what's the difference? Of course, this is the what it stands for, abbreviation. Okay. Here, data is stored as entities defined in tabular format. Here, data is stored in objects. So it is very clear from the name only. Object oriented means data is getting stored in form of object, and in relational database management system, getting stored in form of a table, tabular format like rows and columns. RDBMS handles simple data. OODBMS handles large and complex data. I think MongoDB is example of object oriented database model. Which one is it? Uh, what type of database DBMS is MongoDB? Non-relational. Okay, this is non-relational database. Okay, fine. Coming back. So the first one, which is RDBMS, is used to handle simple data, and object-oriented DBMS is used to handle the large and complex data. RDBMS, an entry refers to a collection of similar items having same definition. Here, a class refers to a group of objects having common relationship behaviors and properties. RDBMS handles only data, and object-oriented DBMS handles both data and functions operating on that data. RDBMS to keep data independent from application program, that's the objective. Object oriented DBMS to implement data encapsulations. This is more to do with the class, and it's kind of talking about all the benefits that class offers, which is encapsulation, you know, handling the data in functions, relationships, and behaviors. Then this has a primary key that identifies the object in a table uniquely. This one has an object ID. OID represents an object uniquely in the group of objects. Okay. So can you recap this?
Yes. Difference between relational DBMS and object-oriented DBMS.
Yeah.
RDBMS data is in RDBMS data is stored as entities defined in tabular format. In object-oriented DBMS, data is stored as objects. RDBMS handles simple data. Object-oriented DBMS handles large and complex data. In RDBMS, an entity refers to a collection of similar items having the same definition. In object-oriented DBMS, a class refers to a group of objects having common relationships, behaviors, and properties. RDBMS handles only data. Object-oriented DBMS handles both data and functions operating on that data. Um, our DBMS objective is to keep data independent from application program. DBMS is to implement data encapsulation. In RDBMS, a primary key identifies an object in a table uniquely. In object-oriented DBMS, object ID represents an object uniquely in a group of objects.
Okay. Let's move on. Database relation. This is really, really important. So pay attention, Kritika. This is like a base of the whole database relation. And I think I covered this last time also, but I'll go over it once again. So this is your table. There are certain terms like each of these are called something. Some term is used for that. For example, each row, which is the whole this row, one, two, three. These rows are called tuple or record. So if anywhere is talking about a tuple or a record, you know that it's talking about the whole row, which is the horizontal row. Then each column, this vertical thing, columns are called attributes or fields or columns. Okay, these are employee ID, e-name, post, salary, all of this entire thing. Each of these are columns or attributes. Then you have something called domain. For example, let's say that we are going to accept user enters a data for someone, like goes on a website and is filling up the form. For example, he puts the name, the post, and then he puts the salary. For example, he's applying for a job, and in the job he's putting his expected salary, like what he's expecting. Of course, company will have its own norm, like they can't give you 1 crore, right? There has to be a range that they can offer. So that is the range, is something that is defined in the database. So even if the user tries to enter more than that range, it's not going to take it, it's not going to accept it, it's going to give him an error. So that range, like what is the range of numbers or characters or whatever, that is the range is called domain. So domain is a set of permissible values that can be accepted by a specific attribute. So attribute means column. So what? So example, salary can accept values between 5,000 to 1 lakh, not more than that. Similarly, let's say he's trying to enter his name, and he's trying to enter just R as his first name. Uh, and you may not want to accept that just one letter, so you'll put like minimum one character, or maximum. He's from south and he's putting like Chiripalli, Swaminathan, and all of those long names, and we don't want that. So we'll probably put a limit on that, maybe just 50 characters. So that limit is domain. Smallest unit of data in the table is called data item or cells. So we spoke about the rows, which are called record or tuple. We spoke about columns, which are called fields or attributes. Now these individual cells, the E1 and then Rahul, these cells, basically the whole cell, one cell, a single cell, are called data item or cells, and then they contain values. like this cell contains clerk, this cell contains 20,000. Now, the total number of attributes that comprises a relation is known as the degree of the table. So attributes means columns. So what's the number of columns? 1, 2, 3, 4. So 4 columns means degree of table is 4. And the relation name in this case is the table name, which is employee. Then we talk about keys, which are like really confusing. We talk about super key. Super key is an attribute. Attribute means the row element, okay, or set of attributes used to identify the record uniquely in the relation. Okay, so there are multiple records here, and if you have to identify something unique about each row, there has to be something unique, right? So in this case, let's say employee ID is unique. So we can say this whole thing, whole attribute, employee ID, is your super key. Sometimes this may not be unique, like this is E1 is getting repeated maybe twice or thrice. Then we'll have to look for something else. If we can't find something else, then we can combine two columns or two attributes together to form a key. So in this case, maybe post, is post. So if you combine the employee ID plus post, probably we will not get a repetition of that, like a combined key. So that's why it's saying that super key is an attribute, which means a column name, or a set of attribute, which means multiple column names, that is used to identify the records uniquely in the relation. Example, employee ID on its own can be a super key, or employee ID and post together can be a super key, or employee ID plus ename can be the super key. So either of these, since their combination is also unique for each tuple or record. Then you have something called candidate key, which is a single key or a group of multiple keys that uniquely identify rows in a table. Okay. Example, both employee ID and name can act as a candidate key for the table as long as they contain unique and non-null values. So, Maya, do you know what's the difference between super key and candidate key?
Yes, a candidate key cannot be reduced. So, for example, emp id plus ename is not a candidate key because you can remove ename and emp id uh, is still a key. It's still unique.
Okay. Okay. Let's write that. I think it's important. Difference is that, what did you say? A candidate key not
It's not reducible.
reduced, still, which means you cannot remove one of the attributes, right? From it,
Yes.
attributes, uh, then remaining attribute, oops, is still unique. Okay. All right. Primary key is a can. Now we talk about primary key. Primary key is a candidate key selected by a database administrator to uniquely identify tuples in a table. Um, Out of all the candidate keys that can be possibly for a table, there can only be one key that will be used to retrieve unique tuples from the table. For example, employee ID and the name are candidate key, and employee ID can be chosen as primary key. So database administrator chooses one key as the primary key. Primary key can only be one. It cannot, you cannot combine the keys together like the candidate or super key. It has to be just one. So in this case, employee ID is unique. So administrator has chosen that employee ID will be the primary key. When you talk about relation, relation is defined as using two basic aspects: relational schema, which specifies the relation's name, list of attributes of the relation, and domain of each attribute, which is denoted as R, A1, A2, up to AN. So A1, A2, AN, up to these are the attributes. Relation R has n attributes, which is also called the degree of relation. We already discussed that. What was the degree? One second. Degree of the table. Oh, sorry. Yeah, this was degree of table. Degree of table means number of columns, number of attributes. And here, degree of relation is number of. Okay, this is also a number of attributes. Okay. For example, relation schema of relation person can be defined as person, and then we put the attribute name, let's say person ID, data type integer, attribute name, data type, and so on and so forth. That's your schema. So this relation person, which means a table called person, is going to contain multiple columns. It'll have one, two, three, four columns. First column will have person ID, second column will have all the names, third will have age, fourth will have address in form of a table. So this is like a representation of the schema. It's called schema. Since the person relation contains four attributes, so this relation is degree of four. Relation. Now we talk about relational instance or state, which is denoted by small r. It's a collection of tuples for a given relational schema at a specific point of time. So schema is basically the whole thing, relation name and the list of attributes with their data type. Relation instance is a collection of rows for that relation schema at a specific point of time. A relation R of a relation schema R, also denoted by RR, is a set of n tuples. So let's say R equals T1, T2. So this is like a set of rows. And this is instance is denoted by small r. Again, this is another example. Okay, so this is relation schema for student. This is again another example like we have given for person. This is your schema. Relation instance is this where T1 equals these guys, these values for this relation instance, and number of tuples equals 2. And number, each tuple contains 4 values. So let's just highlight a few things. Specifies relation name and a list of attributes. And relation instance is a collection of tuples. Okay, we'll pause here and then we'll just recap our object-oriented programming, because it's important to recap, otherwise we'll not remember anything. Okay, moving on to this. We were done with the object class. What else did we do? We did this. Getters and setters was done yesterday. Encapsulation, inheritance was done. Then we did single level, multi-level, polymorphism, constructor. Order of execution was not done, I think, yesterday. We can directly jump to the static method. Ritika, you want to read?
Yes, okay. Use of static method in Java. The static keyword is used to construct methods that will exist regardless of whether or not any instances of the class are generated. Any method that uses the static keyword is referred to as a static method. Static methods have access to class variables or static variables without using the class's object or instance.
So I'll just recap this. So static methods are those methods uh, which are basically accessible without having to instantiate the class, which means you don't have to create an object of a class. You can directly access them. And of course, you have to use static keyword. for that. So here is an example. Inside of a student class, you have a method called change. This will have access to all the variables from this class. For example, college, it's accessible because it's an instance variable. And if I want to access this particular method inside another class, uh, I don't really have to create an object of that. I can directly access that using the class name dot name of the method, because it's static, and the rule says that you don't have to worry about instantiating, and you can still access its method what's been declared as static. Okay, so that's all that's happening there. Okay, go on. Oh, good,
Ex-
we have something. Thanks, Umay.
what do we have?
uh,
Okay.
so this the answer we didn't have yesterday, so Sumaya has written this answer. This is
Oh,
from the
right, right. Okay. Explain why main method in Java is always static. The static is a keyword which we use in the main method to define it as static. There is no object of the class available at the time of starting Java runtime, and because of that, we have to define the main method as static. By doing that, JVM can load the class into the main memory and call the main method.
Okay, so what he's talking about is, this this main function, right? This gets automatically called when the class is instantiated. So it's saying, why do you have to put static here in the main function? So, and the reason for that is because when the class is instantiated, the object is not available at that point of time. It's available after it's instantiated. Okay, so because it wants to call the main function, and that's where it's getting instantiated, it can call it without having to create the object for that. Okay, so that is why it is static. So if we define main method as non-static, JVM will not be able to call it and throw an error. I thought you were going to put an error here. There's a colon here. Okay,
There
go
was a
on.
screenshot I forgot to put there.
That's all right. You put that in the exam.
Advantages.
Go on.
Advantages and disadvantages of garbage collection. In the garbage collection process, Java frees the dynamically allocated memory, which is no longer referenced. Advantages: it can make programmers more productive. Second advantage of garbage collection is that it ensures program integrity. Disadvantages: it adds overhead to the system, which adversely affects program performance. The programmers in a garbage collected environment have less control over the scheduling of CPU time, as it is devoted to freeing objects that are no longer needed.
Okay. Use a final keyword. So final keyword is basically used to create constants. And this is how you use final keyword. Final int x equals 10. And you know that you can't really change the value of constants. If you try to change it like so, you will get an error. Finalize method will always be called at the end, which means during the cleanup process before the object is destroyed. And this is used to basically do the cleanup. You can do all the cleanup work here. It's called by the garbage collector before destroying the object. This method helps garbage collector to close all the resources used by the object and helps JVM in the memory optimization. Write a program that takes three numbers as input and displays the largest among them. You've added that, no? Sumaya?
Yes.
Okay, good, thanks. So, this was from the exam question paper. So it's saying that write a program that takes three numbers as input and displays the largest among these. So we know that whenever we want to take an input from the user, we have to use the scanner class, which is part of the java.util package. So we'll import that, create a class, create a main function. Inside of that, we'll instantiate this scanner class, and we have to pass the system.in because this allows us to take the input from the user. We store it inside of an object called scanner. Then we create an integer called max, and then uh, do we not need to import anything to grab hold of this integer? No, right?
No, it works without importing.
Okay, so we have. So what is this actually? Is this class or what is it? This integer.
It's a subclass of the number class, I think, integer.
Okay, so integer dot min value is going to give us the minimum values, kind of give us a point with which we can compare. So we store that in the max, and then we loop through three times. We ask the user for the number. Okay, so we print this message. What is this x doing?
VS Code shows the name of the parameter.
Okay, okay, no problem. Okay, so now in order for us to read the input whatever user has entered into the system, so this function inside the scanner class is allows us to read it from the keyboard. So we'll call scanner.nextInt. Whatever user enters, whatever number he enters, we'll hold that inside of the input variable, and then we'll say max equals, so initial value was this, max equals, if input is greater than max, then the maximum will be input, otherwise it'll still stay as max. Okay, so this is the logic we're doing. So this is a very smart way of doing it. I like it because uh, rather than first running one loop and taking the number from the user and then again running another loop and then comparing those values, we're doing it at that point itself, which is taking the number and immediately checking if it is not the maximum, or if it is maximum, then storing it inside of the max basically. So whatever he enters, if it is higher than this guy, we'll store it in the max, otherwise we'll keep it to max. Next time he enters something, if new one is higher than the previous one, again we'll store it inside of max. So at the end we'll be left with the largest number, and finally we just use println to print that particular number, and then we close the scanner object class. Okay, enter number minus one minus two. Okay, so this is the output of that. Good. Okay, so now talk about features of Java. Samaya.
Features of Java. It's based on object-oriented programming concepts. Everything in Java is an object.
They might ask this in the Viva, I think, because
Mm.
yeah.
Objects promote understanding of the real-world problems in a natural way. They provide practical basics for implementations of the design of the system. Simple and secure. Java is easy to understand and write, having user-friendly syntax. We can develop a virus-free system using Java programming language because it has no explicit pointer. It runs inside a virtual machine sandbox. Portable. Java facilitates you to carry the Java bytecode to any platform. With the help of bytecode, you can run the Java program on any computer virtually. Java provides three types of portability: source code portability, CPU architecture portability, and OS GUI. Robust. Java provides an automatic garbage collector that runs on the virtual machine and destroys the objects which are not being used in the program anymore. Multi-threaded. Java runtime systems come with an elegant solution for multiprocess synchronization that enables you to construct smoothly running interactive systems. Architecture neutral. Java Virtual Machine was designed to write once, run anywhere, anytime. Interpreted and high performance. Java bytecode can be translated into native machine code using just-in-time compiler, which is faster than the standard JVM. It also facilitates running one time and caching the results for future. So Java code
Yeah, so
is
this is
compiled by Java compiler.
yeah, so this is your .java file compiled by the Java compiler into the bytecode, the dot class file. It's going to use all the libraries, and then this is a demonstration of that it can run on any of the JVM, whether it's Windows JVM or Linux or Mac. That is why it is called architectural neutral. This code can run on any JVM on any type of machine. Keep on.
Distributed. After compiling the Java program on one machine, it can be transferred on another machine to execute because of its bytecode facility. It supports remote method invocation, which enables a program to invoke methods across a network. Dynamic. Java programs carry substantial amounts of runtime type information that is used to verify and resolve accesses to objects at runtime. This enables to link code safely and expediently and dynamically. Using class loader, you can also load a new already compiled class at runtime in a standard language supported way. Java development environment and tools. You can write, compile, and edit Java programs in two ways.
You remember what are the two ways?
Using an IDE or using a command using the
Yep, command line, correct.
command line environment or integrated development environment. NetBeans and Eclipse are two free and popular IDEs.
I think they forgot to mention the IntelliJ. That's also free.
The key components of Java development environment are JDK, Java Development Kit, JRE, Java Runtime Environment, JVM, Java Virtual Machine, JIT, Just-in-Time Compiler. The components JDK and JRE interact with each other to create a sustainable runtime environment that enables the seamless execution of Java-based applications in virtually any operating system.
I think they can ask these questions like explain JRE, JVM in that short questions. Like towards the end, normally they ask write short notes on these topics.
Yeah,
They might ask this there. At least we should know what they are. So this is a diagram, and every application comes with a JDK toolkit, and inside of which you have GRE, which basically is the class library. Then you have the JVM, and inside that you have the just-in-time compiler. So every module of Java comes under JDK. GRE is a class library. JVM is an instance of GRE while executing Java program. So JVM is an instance of GRE, and because it's a class, so class its instance is this JVM. It's a runtime interpreter. GIT is a part of JVM that is used to speed up the execution time. So the job of this is to speed up the execution time. How it does that is by compiling the parts of the bytecode that have the similar functionality simultaneously. So all the bytecodes that have similar functions, it compiles them together simultaneously at the same time. JDK Java Development Kit. It is a software development environment which is used to develop Java application. It contains JRE, Java Runtime Environment, along with development tools. Contains JDK, Java Development Kit, contains private Java virtual machine, and a few other resources like interpreter, loader, Java compiler, archivers, Java doc for documentation generated to complete the development of Java application. So let's just do some. This is a software development environment used to develop Java application. Contains private Java virtual machine and few other resources like these guys: interpreter, loader, and Java doc. So Java Development Kit is a software development environment containing JRE and contains private JVM and few other resources. Java Runtime Environment, it is a software layer that runs on top of computer's operating system. It provides the class library and other required resources to run a specific program. Java Runtime Environment um, architecture generally uses class loader dynamically loads all the necessary classes to run a program. It automates the loading of the classes per requirement so it can effectively utilize the memory. Bytecode verifier checks the format and accuracy of the Java code before passing it to the interpreter. An interpreter helps to run the Java program natively on the underlying machine. So, what is JRE? It's a software layer that runs on top of the operating system. Provides basic provides the class libraries and other resources to run specific Java program. Dynamically load, okay, Java environment, runtime architecture, dynamically loads all the necessary classes, checks and formats accuracy of Java code, helps to run Java program natively. Once again, the recap. So Java runtime environment is a software layer that runs at the top on top of the computer's operating system. It provides the class libraries and other required resources to run a specific program. And this runtime architecture uses class loader, which automatically loads the relevant classes, required classes. A bytecode verifier, which checks the format and accuracy of the code. An interpreter, which helps run the program natively. Then we have just-in-time compiler, which is an integral part of the Java virtual machine and garbage collector. It can compile the Java code into machine code, which can significantly improve performance. So just-in-time is mainly to do with the performance. It increases the performance, improves it. Just-in-time usually compiles code as per requirement. Once method execution crosses certain limit, then it will be converted to machine code. Programs written in Java compiled into machine language, but it is machine language for the computer that does not really exist. This is what we call virtual computer and is known as Java Virtual Machine. The machine language of the JVM is also known as Java bytecode. The code helps us to run the program on any computer. Okay, so it's an integral part of JVM and garbage collector. It can compile Java code into machine code and improve performance. And compile code as per requirement. Moving on. So this is the flow of the Java program execution. You usually, if you create diagrams, you're expected to get more marks. So here, this is the flow. First, you have the Java file which you have written. Welcome to Java, for example. That code is compiled by the Java compiler, which basically generates the bytecode by automatically loading. So we remember we discussed that uh, JRE, yeah, just Java runtime environment will automatically load the dynamic all the classes that are required dynamically. So from the library code, and then that is going to be executed by the Java virtual machine, and then output the program, run the output of the program. To run a simple program, we have to use Java compiler to convert the source code into Java class code. Then after that, JVM is responsible for running that program. I'm We have 2 minutes. I think we should do the Java data types tomorrow. Okay. Somebody's asking what does SQL stands for.
Where in the comments?
Yeah, I'll paste it. Structured query language. Cool. Thanks, guys. I'll see you tomorrow. Same time.
Okay, thanks.
Bye.